Hey Algebra 2, today's lessons is called square roots and functions. Now this lesson is definitely going to be more of a basic type of lesson, just dealing with square roots. So let's just jump right into it. The first square root that we have is the square root of 0.25. And we are asked to simplify. Okay, that's like way close. Let me even redo that. Okay. So it says to simplify, can't write right now, the square root of 0.25. So the question is, can we take the square root of 0.25? Now I know y'all can do this on your calculators, but still, an easy way of doing it is cover up to 25. Think about what's the square root of 25 is 5. And if there's two numbers on the right side of the decimal, we're just going to cut that amount of decimals in half. So this would be just one number on the right side of the decimal. So it would be 0.5. So again, if I were to give you 0.036 and say find the square root of that, I see the 36, so I know I'm going to put a 6 here because the square root of 36 is 6. And I count there's 1, 2, 3, 4 numbers. That's not even a word. Numbers on the right side of the decimal. So since there's 4 here, we're going to cut that in half, meaning our answer is going to have 2 numbers on this side of the decimal. So it'll be 0.06. 4 numbers underneath the root, 2 numbers on the outside. Okay? And so that's how we do these. Now, if you were to get a number like this, let's go with 0.144. When we look at this, we see 144, some of us, most if not all of you guys think, okay, square root of 144 is 12. Well, notice that this is an odd amount of numbers, 0.144, so it's 3 numbers. So this does not equal 1.2, like writing the number 12. That does not equal that because, again, this has to have an even number of decimals. So if this was 1.44, you would just take the square root of that. Again, I see 144, so I'm going to write the number 12. And since there's 2 numbers on this side of the decimal, my final answer is only going to have 1 number on that side of the decimal. So my answer would be 1.2. So that's how we do square roots when you have decimals. And with fractions, you have 9 over 49, the square root of that. So what you can do is just take the square root of the top, square root of 9 is 3, over the square root of the bottom, square root of 49 is 7, and that would be your answer. Okay? So you just take the square root of the top, square root of the bottom. Alright, now, another type of problem that you're going to get is, if I were to tell you to evaluate, okay, if I were to say, okay, let's take 5x plus 9 over 16. We're going to take the square root of that. And I want you to evaluate that for x equals 8. Evaluate this root for x equals 8. That means you're going to substitute this 8 in for x. So we get 5 times 8 plus 9 over 16. So that is 5 times 8 is 40, plus 9 is 49 over 16. And now we can take the square root. Square root of 49 is 7. Square root of 16 is 4. So this would be your final answer. So again, first plug in, and then we simplify the top, and then we take the square root. So that is how we do a problem like that. Now, if it doesn't end up being able to take the square root into a whole number, then we're just going to leave it. So if I were to give you 4x plus 3 and still say 4x equals 8, when you plug in, you get 4 times 8 plus 3, the square root of that. You get 32 plus 3, which is 35. Now there is no whole number that is 35. Sorry, I can't talk. There's no whole number when you square that equals 35, so we can just leave this as our answer. Okay? And, alright, so that's how we do those type of problems. So now let's talk about domain. Domain. Again, domain is all possible x values. Okay? So if I were to give you a function here, say f of x is equal to the square root of 3x minus 15. Okay? Say find the domain of this. Well, we know that you cannot have a negative underneath the root. So since we can't have a negative underneath the root, the smallest number that this whole thing can equal would be 0. Now it can equal anything greater than that too. So what we're going to do is take this inside and say this has to be anything greater than or equal to 0. And this helps us find our domain. So now we move the 15 over by adding. Divide by 3. So you get x is greater than or equal to 5. And this would be your domain. What this is saying is if you pick any number 5 or greater and plug it into here, you will get a positive underneath that root. Let's do one more. You have f of x is equal to negative x over the square root of 6 minus x. Now when you're trying to find domain, don't even worry about the top. The top doesn't matter because you can plug anything into a numerator if there's no root that's involved with it. So, I mean, there's no number here that you cannot plug in. So we're just going to look at the bottom. Now, one rule, so we have a root here, so we know that one rule is that you cannot have a negative. So we know that this 6 minus x has to be greater than 0. The question is, it can't equal 0. That's not a question, that's a statement. The statement is, this cannot equal 0. See how this one, it can because it's in the numerator. You're allowed to get the square root of 0. But you're not allowed to get 0 in the denominator. So the only difference with this problem is that we just don't set this or equal to 0. This is greater than or equal. This is just greater than. So now we're just going to subtract 6. You get negative x is greater than negative 6. And then we divide by a negative. And since we divided by a negative, we switch the direction of the symbol. So this would be our domain. There you go. So again, when you have a root in the numerator, when you're dealing with domain, you go greater than or equal to. When you have a denominator, you just say greater than. Okay? That's the only difference with that. Alrighty. Here we go. Let's do another set. Solve. Okay, so we're going to solve each equation. So if I were to give you this, 4x squared plus 9 equals 45. Alright. Now when you're given a problem like this, you don't want to root anything until it's by itself, until you get the x squared by itself. So first we're going to move the 9. So you get 4x squared equals 36. Then we divide by 4. X squared is equal to 9. And so for our very last step, we want to get rid of a square. And the way we do that is we square root. But it's important to remember that anytime you take a square root of a variable, okay, of the letter, this side is going to be positive negative. So square root of 9 is 3. So plus minus 3. Because if you were to go back to this step, if we were to plug in positive 3, 3 squared equals 9. And if you were to plug in negative, negative 3 times negative 3 is positive 9. So you have two answers when you're dealing with squares. Alright, let's do one last one. 3x squared minus 86 is equal to x squared plus 86. Alright, so again on this problem you want to get x by itself. So we're going to move the x squared. So we're going to move that over, and we're going to move this over by adding. Okay, so those cancel out. I'm left with 2x squared is equal to, that's 160, 172. But again, we can't take the square root until we get that 2 out of there. Got to get the x squared by itself. So here, that's going to be 86. Alright, we root it. Now this isn't a complete square, or it's not a whole number when you root it. So we're just going to go ahead and leave it like this, and I'll teach you how to break that down in our next lesson. But for now, we can leave it like this for this lesson. So this would be our answer. Don't forget the plus minus. That's very important. All right. So this is how we deal with square roots, okay, and functions. Okay, so again, decimals and fractions, this is how we do these. You can, again, go over these videos as many times as you need. Evaluate, that means plug in for x and then break it down from there. Plug in, break it down. Domain, set, if it's in the numerator and you have a root, you set it to greater than or equal to 0. If there were no root, we would just set it equal to 0. And then if it's in the denominator, you just don't do the or equal to sign. You just do the greater than sign. And lastly, solve. Don't forget, get x squared by itself before you take a square root. Before you do this, you have to get the x squared by itself. So good luck with that.